Hi everyone, and welcome to Installs, Updates, Repositories, and File Management. Today we're going to be talking about how to install and update a server and its needed applications, how a repository works and why we have them, and we're going to talk a little bit about some of the file system and how it is put together. So the first thing that I would like to talk to you about is a review of permissions. So on a Linux system, we have a set of permissions that is going to be associated with all files and folders and pieces of the system. These permissions will allow us to decide who can access particular bits and what kind of access they have. For example, we can look at directory access and we can control who can actually go inside a directory and who can actually just read the directory. We might end up wanting to use this if we wanted to, say, hide directories on websites. We also have permissions for files. So the way that file permissions work is by default, the owner and the group have read and write permission, and then the world will just have read permission. What you're looking at on the screen is a sample of some different types of files, folders, and a symbolic link. And the way that this is actually put together is the way that we are going to see file permissions is we'll do an ls-l at the command prompt. And then we're going to see a number of characters and then things like the owner of the file and when it was created or modified. And then at the end, we'll see the name of the file. Now, the beginning of this line, we will see a dash if it's just a plain file. We'll see a D if it's a directory or a folder. And we'll see an L if it's a link. The next three characters after that is for the owner of the file. 3 characters after that is the group, and then the last 3 characters is the world. So for example, if we look at our top file, awklab.data, we can see that the owner and the group have read and write permission, but the world will only have read permission. So it means they can see it, but they can't do anything to it. Whereas if we look at file name 2, we can see the owner can read and write, the group can read, and the world can write. And then if we wanted to go down and say look at some of the shell scripts, samplescript.sh, we can see that we've actually added execute permission or the ability to run a file for the owner only. So instead of rw dash, it's actually rwx, and then the next 3 characters will refer to the group, and then the last 3 to the world. Now, the ways that we can go about changing file permissions is we can use chmod, that's spelled C-H-M-O-D, and we can do it using octal numbers, so chmod 744 and then the name of the file, for example. You can also do it if you did chmod, plus R or plus RW, things like that. We can also create hidden files on our system by adding a dot before it. So if you see dot name of file, you know that that's a hidden file, and the only way we could see it is with ls-a. So you can see these are some examples of file permissions on a system. Now, the access to these files and folders can be changed using the commands chmod, chown, and chgroup. The chmod will allow us to change the permissions on the file, so we can mess with what we were talking about before. Chown will allow us to change the file owner, and chgroup can change group members on a file. So normally I would have you do a little activity here, so if you'd like to pause me and go do this activity, you can. The idea is you're going to make a bunch of files and folders, create a group, and then try out each of the different commands and see how they work. Can you get them working? How do they need to be set up? What's going on there? And then start playing with groups. Create a group, add a user to the system, add the user to the group, and then make sure that the user can log in and all of the permissions are working correctly. We can also look at something called system files. Now, these system files are going to be pieces of the system that are generally going to be set up, and it's places that we know things are mostly going to go. Now, I do say mostly because not all servers are going to be the exact same setup. This is just general on most servers that you work with. Now, servers are going to have a directory called root. This is the starting point of the system. This is not the same thing as root or superuser, the account. The root is just where the system happens to start, whereas root, the user, is just full access to the system. In the root folder, we have a bin folder where we might have our executable programs. We have our Etsy folder where you'll see a lot of our config files. The home folder where you're going to see the home directories for all of the users on the system. An opt folder where you'll see optional or third-party software. A temporary folder that is going to hold things that we need right now but we don't necessarily need forever. Sometimes we'll have a user folder. This would be user-related programs. You may also see user/bin or user/sbin. And then we're going to have a var folder. This is going to have data about our variables. We might have websites in here for webroot. We might have log files, and there's going to be lots of pieces of information about our system in these places, and this is the general organizational layout for most Linux systems. So if you ever need to find anything, you can have some general ideas of where it's probably going to live. Now, we do also have some special files. So in a Linux system, we have something called dev null, and this is also sort of known as a black hole. Basically, if you send anything to dev null, it's just completely ignored. It's like it never happened. So you can take standard out and just dump it there, but you can just dump anything there, and it's just basically a black hole of nothingness. We do also have proc, which is an illusionary file system. Think about it a little bit like a task manager, and it's where we can store some other types of information specifically about what's happening in the system right now. Now, the next thing that I would recommend that you do is go through both of your servers and find each of those files in your system. If they are somewhere different than where I've listed, make a note of that. If they are called something slightly different, make a note of that, and then see what's in them. You can see some of them are going to have more stuff than others, and you can get an idea of some of what's in there, so that if you do need to find information in the system, you'll start getting a little bit more comfortable of where that information is going to live. Now, another activity that you can do is create a script. So we can create a script to back up, in this case using tar. Now, the reason that the script to back up and script to collect data usage is in the section on installs is because when we do anything with installs, updates, or repositories, it's going to be really important that we can go back if something goes wrong. So having a backup snapshot of your server, a backup of all of your files is going to be really important, because when you're doing installs, updates, or doing anything with repositories, if anything goes wrong, you want to be able to basically undo it, and this is how you would get that undo button equivalent. So try writing a script to back up using tar. I've included a video of me talking about tar and how it's used. You could also try writing a script to collect a data usage report. This can also be useful to see if anything happens to be eating up more of your system than it should. For example, maybe a user has set something up and it's replicating in a way that it shouldn't, or a program's gone wrong and that's adding things that it shouldn't. It's important to keep sort of an eye on these things as we're doing our server admin work, so that we can try to figure out if something is going wrong, we know it sooner rather than later. Now, the next thing that we're going to talk about with doing installs on a server is repositories. So, as we were talking about how a server is put together, where things are located, the permissions and access that we have on our server, the next thing that we can look at is how we are going to actually go about installing programs on our server. A repository is a place where programs live. It's a way for us to be able to collect and organize the software. You'll sometimes also see it referred to as a personal package archive or PPA. Basically, the way that this works is we have a set of software that is going to be compatible with our system, and it's going to live in this repository. It's this area that we're going to save all of these things to. Now, by we, I mean the people that are either creating the system or created the repository. I don't necessarily mean you right now, I just mean this sort of general way. And so a repository allows us to actually organize our programs based on the computer they are compatible with. So like if I have a program that is compatible with Ubuntu, I could try to make it into the Ubuntu repository. If I had one that was compatible with, say, CentOS, I could make it into the CentOS repository. And that way we don't have to worry as much about, is this going to be compatible? Is this going to work with our system? If it's part of the repository that was given to you with the system install, it's already been tested to be working, so you have one less thing to worry about. Now, the reason that we have them is because it's a way for us to be able to organize software. We can have operating system updates in there. We can also organize our software in there so that we can see what's actually compatible with our system. And we can split the repositories up. So we can split it up by versions or kernels, and it ensures that we are able to stay compatible. So anything that we are installing, we know is going to be compatible with our system. We don't have to worry about trying to install something and it isn't compatible and it doesn't work and it doesn't install, or, permanently breaks the system. If it's in one of the repositories that was given to you as part of the original install of the server, you know it's already gone through some testing. So you have that extra little sort of cushion of this is more likely to work than other things. Repositories also give us the ability to split things by version. So for example, in Python, we have Python 2 and we have Python 3. So we would be able to say this is the repository of Python 2 programs, this is the repository of Python 3 programs. So we would be able to access them separately if we wanted to, because they aren't interchangeable. Now, we have some common repository names. So we have standard and non-standard. Standard means it comes with the machine. So when you first installed your server, you have some repositories that are already on your repo list. Repositories can also be referred to as repos. Standard comes with it. So that means it's already been checked, it's already been found to be compatible, they should be limiting what's going in there a bit, so you already know that it's going to be working. Non-standard means it has to be added separately, and we're going to talk about how to add repositories in a minute. Ubuntu has some slightly different vocabulary here, and you might find this with other more off the beaten path systems as well. So Universe is community maintained and open source. Multiverse means that it's actually copyright restricted, which you may or may not care about. The main repository is going to be all of the supported programs for Ubuntu. The restricted repository is going to include some proprietary programs. It will also sometimes include device drivers. Now, we are going to talk about drivers more in the next topic, but basically, a driver is how we can have our hardware communicate with our software, and that absolutely has the tendency to be more proprietary. Proprietary means it's owned by a company. The source code is not out there for anybody to use. Now, the next activity for you to try on your systems is to go find on both of your systems what repositories are already there. Where did you find them? And then start thinking about why we may want to add repositories to our system. Feel free to pause me for a moment and go do this and work through both of your servers and try to answer these questions and write down some notes about your servers. Now we can talk about adding a repository. So for any of this system level stuff, we're going to need to use sudo. So you remember from the previous topic on user management, sudo gives us the ability to run a command with elevated privileges, root privileges, to install a repository, because this is something that is going to be done to the system. It needs to have the administrator give permission. So you're going to need to use sudo. A general user would not be able to install a repository without sudo permission. I have some examples of how we could go about doing this. Now, in some cases, it's actually done at the command line. In some cases, you can go edit the sources.list and add repositories there. In some cases, you're going to see some scripts that will pull repositories, and this is actually very much going to depend on your system. So whichever system you have, you should make sure that you know how to add a repository to that system. On the website, there are some links on some examples of exactly what to type in to add a repository. This, however, brings me to my next topic, which is very important: repository safety and use. Adding unknown repositories can be a safety risk. When we have a repository that's basically saying, yes, please play in my system with full privileges, do whatever you want, it's fine, don't worry about it. Now, while that may not panic you, if you are going to be doing any sysadmin work, kind of it should, because giving anybody that much access to your system can absolutely run into some problems. So some things that you want to think about as you are doing this is, if you are adding a repository, do you absolutely need to, is the first thing that I would ask. Is there another way around it? If there isn't, and sometimes there isn't, or it's you need multiple things from this repository, or it's a really common, well-known repository, something like that. So if you still have to add a repository, the first thing that you want to think about is, do you trust the person hosting this repository or PPA? The next thing that you want to look at is how many people have safely used this before you. So this is where we start getting into some of the cautions. In previous classes, I'm sure you've Googled the error and just typed things in blindly and then gone, gee, this works, how lovely. However, at this point, you do need to start questioning what people are doing, what people are telling you to do, and understanding what you are typing in more depth than you would have needed to in previous areas. Once you are talking about giving this kind of access to anybody in your system, you have to start thinking about how much you actually want to trust them. So if you just see some random person on Stack Exchange saying, type this and everything will work fine, you should take that with a grain of salt. Look at what they're asking you to do, look at where it's coming from, and start thinking about things like, is this a commonly used repository? Is this a popular repository? If I Google about this repository, who are the maintainers? How often is this being maintained? How up to date is this? How many other people use this and reference this repository? How well trusted is the community around this repository? And there can be a wide range of answers. There can be everything from, oh yes, this repository is not already in the system, but it's generally used, it's very safe, lots of people have used it, the maintainers are very well known in the community, to random person on Stack Exchange said to go do it, and anything in between. Now, the next thing that you have to ask yourself, is this repository still in testing, or is it production ready? So that can give you some ideas of where your repository might live in that spectrum of working. So is this, hey, I have this repository, I've been working on it, would you like to be one of my beta testers? Or is this, hey, I've had this repository out in public and people have been using it for the last 20 years? Now, for those of you that may not know, a beta tester or an alpha tester is somebody who is going to be going and trying software, hardware, game, whatever it happens to be, and they are some of the first people trying it, so they're going to be the ones finding the problems. In general, alpha testers are the first people other than the creators that have tried it. Beta testing is when it's gone through the alpha testing phase. It doesn't seem to be breaking stuff anymore, but they need to widen the pool. So, like if I had something that was running and I had 10 friends, I would have them try it. They would be alpha testers. Once they've tried it, I would open it up to, say, my students, and then I would have, 200 students be beta testers. And that's how I would do my scaling. And that's how, a lot of people might do it, except, replace students with people they find on the internet. And then the last thing to think about with repository safety is, can you troubleshoot? So, do you understand what's happening enough to be able to fix it if something goes wrong? So, it's really important that you go through and actually look at what you're doing. Make sure you understand what you're doing and understand what's going on. If you have a command or you have a set of commands and you're not sure what's happening, make sure you go and look up each piece of that command before you type it in so that you have some assurances that if things go wrong, you can go back and fix it and you understand what's happening and why. And the last thing that I would like to talk about today is patches, updates, and upgrades. So, as we are talking about our server and our systems, we are going to end up having to do some patching. We are also going to have to do some updates and upgrades. Now, with all of this, we are going to have to do testing. One of the things that I do always recommend to everybody is make sure that you test before you do rollout. Rollout is where you are sending your updates, upgrades, patches, whatever it is, to all of the systems or to all of the users. A patch is specifically a way to fix a critical error. So you'll see a lot of things in the news about patching a program or patching a bug or patching a 0-day. And the idea is that we had something that went wrong, either mildly or very, very wrong, and we need to be able to make that fix really quickly. An update will get the latest version of programs but doesn't necessarily install the programs. An upgrade should install the newest version. If you do an install, that should install the program or update to the latest version if that program is already installed. All of these options can cause issues, which is why we want to test them before we send them out. Usually, what a lot of admins will do is they will have a sample server that is set up just the way the other servers are. They'll have a sample computer that is set up the way all of the other all the other computers are throughout the whole company. And then they will do the testing of the updates, patches, upgrades. They will do all of that testing on this sample machine. And the reason that they want to do it on the sample machine is because if anything goes wrong, they need to know how to fix it, what went wrong, and then decide if they are ready to send this out. For example, Windows does something called Patch Tuesdays. There has been quite a few disasters on Patch Tuesdays where Windows will send something out. And I'm sure they tested it, it's just something that happens. But Windows will send something out and it won't work. And it will break a lot of people's computers or setups or configurations. We'll also see sometimes that some of these updates, upgrades, and patches can also be incompatible or cripple a system. So let's take a for instance. Let's say, for example, I have some accounting software, and this accounting software is a little bit older because some of the extras that we need for our company only work on, let's say, version 2, and they're on version 5. So as I'm doing my updates or patches for the system, I have to make sure that I'm checking on this version 2 of the accounting software. Checking it against version 5 of the accounting software isn't going to help me because that's not what we're running. So I need to make sure that it isn't breaking this accounting software that the, let's say, budget people or accounting and finance use, because I don't want to basically cripple their systems for a day or a week. I want to make sure that when I do this rollout, they are able to still access everything the way that they need to be able to. It's also important that we have this tested with our particular configuration. Most companies will make changes to the default configurations on their systems, so it's important that we test all of these patching, updates, and upgrades against the specific configuration that the company is using to make sure that everything is going to get along well and everything is still going to work the way that we expect. So that is the end of this particular topic. So we talked about how to install and update a server, how a repository works and why we have them, and talked a little bit about how servers are set up. Thank you very much for joining me, and I hope you all have a lovely day.